Hello, everybody. Thank you so much for joining us for Data Intelligence with Databricks on AWS. Before we get jumped into content, I'm going to run through a couple of housekeeping slides. So you'll see a feature at the bottom of your Zoom that has a chat bot with Q&A listed. Please ask any questions that you have for our subject matter experts or session hosts here in the Q&A. The chat has been disabled, but we will be providing plenty of updates in the chat with links and everything that you need to participate successfully today. And if we don't get to your questions, we'll certainly follow up after the event concludes, and we will get a list of those questions and who asked them. I will mention this a handful of times, but the session will be recorded, and the recording and slides, along with all of the links that you need to access the lab post program on your own time, will be shared post event. You can expect that will be sent out mid tomorrow morning. And again, I will be providing a ton of links throughout the session in the chat. You should be able to copy and paste if you do have any challenges there. Please just make a note in the Q&A and I'll send it to you there. For the lab, and this screen will populate twice, so no need to screenshot this here. And again, I'll put it in the chat. We will be using free edition today. So if you have participated and used free edition prior, you'll be able to just log in. If you're new to it, please take a moment to sign up. And before we jump into the hands-on lab, we'll take a brief pause to do that as well. Sometimes folks have seen better success with their personal emails with some restrictions with their company emails. So please make note of that. And then you'll see those best practices listed below. Without further ado, I'm excited to introduce Sue, who is going to run through the keynote session for today's workshop. Thanks so much.
Hey everyone, it's great to be here today. Thank you so much for being here today. I saw the list of companies and people that have registered, and I'm just thrilled to be able to get to spend a few minutes with you. Talking about Databricks is probably one of my favorite things to talk about. I'm sure my friends are very annoyed by it. I joined Databricks about 4 years ago from AWS and continue to be inspired every day. So I assume that if you're here, you probably know a fair amount about Databricks. So I'm just going to run through a little bit about us as a company and the technology and how we hope to democratize data across all industries using the Databricks intelligence platform. So we now have about 15,000 global customers. I want to say we're north of 10,000 employees at this point, $1.6 billion in revenue. We have taken $4 billion in investment, with most recently announced a Series K investment. AWS is one of our sponsors for today, and they were investors in Databricks in our GH&I rounds of funding. So we work very closely with them and are thrilled to have them here today. Databricks, as you may know, certainly going as far back as 2013, was the inventor of Apache Spark, and since then, also the inventor of very popular open source products, Delta Lake and MLflow, among others. We are recognized by Gartner multiple years in a row as leaders in database management systems and data science and machine learning platforms. So super proud of what we've accomplished at Databricks, and thrilled to have you join us. Okay, and this is the time where my slides just don't want to advance. Super love it. There we go. All right, we're back. So one of the things we believe at Databricks is that regardless of what industry your company is in, the winner in every one of those industries is going to be focused on becoming a data and AI company. The value of your data cannot be overstated, and the way to some extent leapfrog your competition is to leverage that data to the largest extent possible. So if you think about leaders in lots of industries today, like Uber, Amazon, Google, they have gotten there by leveraging data and AI. And we now have 15,000 customers and over 70% of the Fortune 500 leveraging Databricks. Most companies know they have to do better at leveraging their existing data and applying AI, but it's super complicated. Um, Most organizations struggle to realize this vision. And you can see when you think about all the different aspects of the data estate, how complex it is. There are different ways to run each of these software pieces. They're siloed functions. Stitching them together can be very difficult. Data warehouses is where you put all your structured data. When you have a data lake for all your unstructured data, you have BI platforms to visualize all that data and understand. Data science and ML platforms get segmented further sometimes, where you're creating copies of your data, which we highly recommend against. And then you think about the governance that's required for all of these siloed areas of data. It is extremely complex and it's incredibly expensive. I mean, these silos create privacy and control challenges. And then the other thing is that they're dependent on highly technical staff. That is really a problem when you want to do what Databricks is doing, which is democratize data and allow business users the same access to Databricks that technical users have. And we'll talk a little bit about how that's possible. I know it seems shocking to give a data science platform to business users, but through Genie and some other tools, we can do it. Pardon me. All right, let's move on to talk a little bit about the data lakehouse, which is kind of where we started. So 5 years ago, we created the lakehouse to start to solve these problems. So instead of data silos, you store all your data in a low-cost data lake. And for AWS, of course, that's S3. All the data sits in S3, it never moves. You own the data. It sits in your AWS S3 account. It's not locked in a proprietary format. The data is then unified under an open management layer to provide performance, reliability, open sharing. That's the open source project called Delta Lake. So this was a critical breakthrough when we created the data lakehouse. Again, this was several years ago. You now hear lakehouse from companies like Snowflake, like AWS, like Google. It's kind of catching on. People are like, yeah, it doesn't really make sense to have these data silos, at least those two big ones, data warehousing and data lake. So on top of that, we now added a consistent approach to security, governance, and cataloging, and we call that Unity Catalog. This is huge, and it enables really the data intelligence platform. We'll get there. From there, once all your data is in the lake, all those circles on the previous slide just become veneers that directly access one copy of the data through one governance mechanism. So we've kind of crushed all those silos, at least from a user standpoint. That means you can do data warehousing, you can do workflows, you can do real-time processing, you can do AI on one copy of the data in a secure way. So that's the lakehouse paradigm, and we've seen a tremendous adoption of that as a category since we created it in 2020. We actually have research to suggest that 74% of global CIOs report that they have a lakehouse within their data estate. So it has definitely caught on, and I think we're onto something. So let's kind of move on and talk about the data intelligence platform, which is the kind of next evolution of the data lakehouse. So hang on one second, let me get to the next slide because I don't think that really, there we go. Let's build this out. There we go. All right, so we took the data warehouse, we added generative AI, and we acquired a company called Mosaic ML in 2023. We brought those two technologies together to create a new category. We call that the data intelligence platform. It opens up just a whole new world of possibilities to democratize data and AI across an organization. So let's talk a little bit about that. It builds on the lakehouse. The unification data and governance is foundational to making a data intelligence platform work. And then we combine the lakehouse with an intelligence engine. This uses generative AI models to understand the semantics of your data and uses that understanding across everything in the platform. So let's look at some examples of what that means. In Unity Catalog, you can securely find data and understand tables with natural language that uses your company jargon. So like, for example, in Databricks, we have over 500,000 tables. Finding the right one is a huge challenge, but because the intelligence engine understands our data and the relationships between that data, one of our developers can be guided to the right data just by asking. In Delta Lake, the intelligence engine is able to automatically optimize the data for you, and then you don't have to worry about things like indexing and partitioning yourself. In data warehousing, we're able to do a lot behind the scenes to optimize query performance. So one thing that will deliver a lot of simplicity and efficiency for your analysts is text to SQL. You just need to specify queries in natural language, and Databricks will generate the necessary code. For orchestrating jobs, the IE automatically selects the right instances and start time to hit your requirements. So this is huge. It handles things like auto scaling and error remediation on its own for you. And then for the jobs themselves, we can do automated data quality monitoring. So we can detect when model quality is skewing, automatically flag it, and then assist in remediation. And then we're super excited about how the platform enables you to build your own generative AI applications. Let's flip through. This is the build. Sorry, I probably should have clicked on those as I was speaking, but that's fine. So let's talk about this other piece, this Mosaic AI piece that we added to the platform in 2023. You can build both models from scratch or tune existing models on your data to maintain privacy and control. You can serve those models really efficiently. And then we can help you do RAG to build like conversational agents with APIs. But it's not just about building and serving models. Databricks AI covers the end-to-end AI workflow, which helps you deploy and manage models all the way through to production. And that's really what it's all about, getting models to production. We provide transparent AutoML to help you find the best model quickly. And then we monitor our own models to give insight into how they're evolving in production and identifying drift, like I mentioned before. And then really most importantly, governing your models. We can help ensure that the results are reproducible, they maintain your standards and compliance rules. And then best of all, and this is a common thread that you'll hear from Databricks, it's all built on an open foundation of ML flow. So it integrates really well with the AI ecosystem. Again, your data is not locked in. And then last, how do we really democratize data and AI for everyone in the organization? And this is where we start to get next level. There are so many teams within every organization who know what they want from the data, but they don't have the skills to get the answers. And speaking for myself, I am one of those people. I'm a business user of data. I am not a technical user of data. So this is where the intelligence engine or the IE really shines. It's a new initiative that we've called Project Genie. Anyone in your organization can use natural language through a simple interface to get answers and visualization. So no notebooks, no code, just ask a question and get an accurate answer. It's something that we think is really phenomenal. Whoa, voila, there's Genie. Excellent, that whole thing built. So Lakehouse plus generative AI gives us data intelligence, which enables us to democratize data and AI at scale, which was never possible before. So data is now accessible to everyone, and the experience of using data and AI can be radically simplified for everyone. It's super simple. You don't need to be an expert to tune the Lakehouse because we're using AI models throughout the platform. And then finally, you can build your own AI and fine tune it based on your own data. You own the data, you own the IP. That gives you a stronger competitive and economic advantage. You can apply AI to every layer of data to drive universal automation and cost efficiencies that's very specific to your business. So hopefully that helps kind of give you a bigger picture about the vision that Databricks has for every company. I hope you're excited to jump in today and get some experience using the platform. I'm going to pass the mic over to our next speaker, I think. Oh, we're going to go right in hands-on lab. So Sophia, maybe this is a good time for you to take over. Again, here's the URL to jump in and get the Databricks free edition started.
Perfect. Thank you so much, Sue. And yes, the information is presented here on the screen. You'll want to visit this link. It is also in the chat. You should be able to copy and paste. If you have any difficulties doing that, just send us a note in the Q&A and we'll make sure to get that over to you. And I'm going to populate next slide, excuse me. And my recommendation is to screenshot this page. You'll need it a handful of times throughout the hands-on labs. So just nice to have and to reference. But again, that is also in the chat and I will share it multiple times. So without further ado, I'm going to pass it to our hands-on lab team to jump into the sessions. Thank you.
Hello everyone, welcome to this hands-on session. And today I'm going to cover a series of demonstrations how to use the features of Databricks Lakehouse platform, starting for ingesting the data, processing the data, and using this data, keeping, organizing in a central unit catalog. To start, we would like to review the instructions they gave for us in the chat. First step is to go through free edition session. Databricks, as you know, now has an environment completely ready to use to apply our knowledge. So I invite you to go to the free edition, sign in if you already have an account. If not, you can sign up directly from here. And by this point, you can just inform your email alarm. So for example, I can use my personal email, but I can do use another kind of email. So I'm already connected and have access to this workspace. This is the first screen you should see. It came up as soon as you log in, and you already have a completely useful environment to try and put in practice this use case. Bueno, so we're going to talk about a use case related to a customer C360. And customer 360 is basically the idea is to identify customers with potential customer churn risk. And to do that and go ahead with this demo, we invite you to put in practice with these instructions. First step, copy this information and go to the Databricks platform, new notebook, and new notebook you can paste here. And after that, add another code here, copy the second part of this code and paste here. With one, the next step is to take some clusters available. We already have serverless compute available for you. And serverless compute is going to start a compute to run the cell. Start by running the cell. And this first cell is basically installing Databricks demos. DB demos is a library which have already all you need to set up this demo. As soon as finishing, you are going to have access to the next cell, and the next cell we can run. And look at this. The main option default has this option you can see there, but if you look in the chat, you already have the instruction as well and can move on. You can also, as the instruction suggests, you change from the main to workspace. What means? It means you have an organization of catalog. In catalog, you already have the option workspace as the first option. As you can see, a home here icon, and you already have a main. As suggested by the documentation, you can replace for workspace, and all assets you should deploy here is gonna be here. You don't have any other schema created already. Only ops and default, and this is the internal information schema for the unit catalog. As soon as finish this demo, we're gonna see here the information of a new schema. If you already had run it before, it's gonna have this message. It means you should replace it. In my case, I already ran before, and I put in the main. So for me, this information is here. This should appear after you run this code. I'm gonna move on to the another pipeline I ran before, just so you guys understand. So I'm going to workspace. Workspace, I can see a folder, and this folder Lakehouse Retail C360. I'm gonna click, and this is all assets we're gonna use for this workshop today, starting with data ingestion, after that data governance, after that AIBI data warehouse, and data science ML, generative AI, workflow orchestration. Everything you have created here, we're gonna use it for this workshop. And the good news is in free edition, you can go after the session training using, analyzing this information. As you can see, there are a notebook here, the first one, 00. This first notebook is created after you run this code. In this code, you have the possibility to check every workload if it is possible to run in the platform. Databricks Data Intelligence Platform has all you need to run your workload: ingestion, transformation, uh, data warehouse, machine learning for data science teams, generative AI, and orchestration. And the idea of this demo is use the AI in the platform. As you can see, the platform, you have a star, and this star, you have a Databricks assistant. Databricks assistant can chat with Databricks to ask about code, to generate code, to evaluate code, to make it clear, to documentation. There are a lot of options here from artificial intelligence there. So another point is simple tools. Ask question. Is secured? And in this case, we're gonna have today, the first step is understand the challenge, how to reduce customer churn with Databricks, and the exercise proposed has the solution to unify the data from data engineers or data science. Everyone has the opportunity to check. I'm gonna close this menu just to gain more space and analyze each step as a point of view of data unification. We have John, our data engineer, are going to build Delta Live Tables pipeline. I have to say, we are changing this name, Delta Live Tables, for Lakeflow pipelines. This is the new name. We're gonna name it in the feature available is responsible today to create pipelines and transform, ingest and transformation of this data. And the idea here is basically show how to connect to distinct sources and collect data from, for example, CRM, ERP, web analytics, mobile app into a unified customer 360 database. This is important. This observation is important here because you're going to create a single source of truth, a dreamed single source of truth. And if it's possible as well to use real-time data ingestion capabilities. And the second point is about, okay, I have ingested the data into the Lakehouse platform. How can I govern this data? How can I ensure security? How can I, for example, allow certain users to use it and others do not have access at this moment? So is it, and we already have a features to ensure, for example, how secure certain hosts is not, will not appear for certain rules. And we can also hide some columns, mask some columns, a lot of features to ensure security on this data. And another point, as BI analyst, and in this case, we have, look at this, the rules. The first one is John, responsible to ingest the data, to transform it, to prepare this data. For Emily, responsible for data governance. Alice is more to analyze the information loaded. And Lisa, using for generate use cases based in generative AI. The first step is to ingest the data and prepare this data for consumption. And for that, you're gonna work with Lakeflow Connect. Let me duplicate the screen to show you. I'm gonna duplicate only to show you where we can find these features. Those features can be found here in data engineering, data ingestion, and Databricks is working to provide Databricks connectors. We already have some connectors available here for SQL Server and Query Hold available connector. It means for example, Teradata, for example, another kind of data, you can check also by catalog and catalog external data. External data, there are an option, connections, and connections going to create connections, and there are a list of connectors available to you connect from Databricks today. For example, Amazon Redshift, for example, Synapse, Databricks. Another Databricks is not from your company, or maybe if you have another distinct Databricks, you can connect distinct regions Databricks as well. So, and HTTP, SharePoint, MySQL, Oracle, Postgre, Power BI, and another questions, as you can see, for example, Teradata and Workday reports last one. It means it's more. Databricks is providing through this platform not only the power of transformations data, but also connected directly. In another moment, we use it to use another tools, for example, Glue, for example, Azure Data Factory. And the idea right now is you can access directly from the Lakehouse platform to this source. Moving back to the end, this is the Lakeflow Connect. Lakeflow Connect is the way you can connect, and here we have a tour, as you can see, explore more about that, dive in, and understand which more can be done with that. Well, good. Now Databricks simplify the ingestion by interactive pipelines. And I have to show you because it's pretty important to know by this section, jobs and pipelines. You can go there and you have this is connecting Lakeflow Connect, Lakeflow Pipelines, Lakeflow Jobs. Each one has specific features. For example, this is connector, this is an editor, and this editor is to create your pipeline, your transformations. You can use SQL and Python as well, and you can start an empty file or look at for another example by notebooks, for example, preset it. And if you can go to the SQL, for example, you're gonna have a completely editor, organize your assets, start this transformation by notebooks. For example, if I go into the sample exploration, it will open a notebook and you can start analyze your data and look at this structure of the information. You have all you need to start this transformation by a lake, a pipeline. And it's important to you know this demo. If you open the DLT pipeline or the SQL notebook, look at there are other names as well. You can also add this case. And if someone has question, we invite you to put in the Q&A sessions. And it's important to know if you guys was able to connect in this free edition and to run this code and to get access to this notebook. As you can see here in this folder, I'm going to click in this folder. We are exploring the first one, but we do have to go into each session and start. So I'm going to accelerate here right now, just make some introduction. And from the point of view, the securing data governance, we have unit catalog. And unit catalog is the central layer to communicate with every object or data and has a centralized way to analyze your data with the control, access control central. And in this case, we're gonna go to analyze the information generation. Databricks Lakehouse Unify. So once you load your data to the Lakehouse platform, you already have the possibility using data warehouse, and you're going to do some SQL quiz and connect to another BI tools. And the fourth step is how can I effectively start predicting churn using the data science tools or an auto machine learning. Auto machine learn, as the name says, is how to automate the machine learn and save some time. And By the last step, we have the 5 transform prediction in action with GenAI. So this is pretty important. If we don't have enough time to go ahead at the final lecture today through this workshop, you can go and follow the instructions in using this step generative way, and you can check as well the workflow orchestration. So the first step here right now after this introduction, and as you can see, the asset generated is a dashboard. In this dashboard, is it possible to identify your clusters, your customers with propensity to campaign and send target email campaigns to these customers, and most likely to churn. Active. And after that, review all the process you have to analyze the information flowing into this lake house. How the information is generated, is processed, and analyzed into the Databricks. In conclusion, we're gonna cover data ingestion, data analysis, data warehouse API is a pretty good workshop. So I invite you to try each step starting by data ingestion. So start by data ingestion. As you can see here, there are 2 notebooks. The first notebook is about using Python to create a pipeline, to build this pipeline and show how to load the data into the lake house. And the second one is access the log analysis, review how was the information was loaded. And well, let's go beginning from here, churn pipeline. Again, I'm here in this 00 notebook. I'm going through data ingestion and data ingestion by the folder. If you can see the folder, please click on this folder and open the options right side. And the right side, you're gonna go to the 01.3. And 01.3, what the idea? First step, let me close, take a compute, and this compute is a cluster, a serverless cluster that Databricks provide into this free session or free edition. And now we do have a cluster to execute your code. And now we're going to start by running the first cell, and this first cell is already using MLflow 3.1 and gonna start installing some dependencies, and all of you need to run our exercise today. After that, let's see how it works. It's okay, just 22 seconds. Going through the next session. The next session, we're gonna show you how to data engineer with Databricks to build your C360 lake house, and basically what it means. John, today, as a data engineer, spent immense time hand coding, preparing transformation, complex dependencies, building frameworks to enforce quality and taxes. But it's not a problem of John only. 73% of the price data gets used for analytics and decision making today. And Databricks can provide a solution to simplify the ingestion and transformation with Lakeflow Connect. You already know Lakeflow Connect is the connector through this kind of database available, and Delta Live Table or Lakeflow pipelines to make it more used to use, is more used to the Lakeflow pipelines. We're gonna cover how to do that. And the first pass, we want to ingest the data sets from Salesforce Sales Cloud and blob storage. So we have some folders here in the blob storage, and we'd like to incrementally load into our data warehouse tables. Why? Why? Because there are customer profile data in some tables, and another part there are orders history, and in this case streaming events as well produced from applications. The first step is ingest a data with Lakeflow Connect. So we're gonna Here we have, you can click and gonna have access to the product tour, and product tour is quite interesting because you can click and see how the thing is going. For example, new, add upload that, Salesforce, and start informing and start connecting a destination catalog and create a connection directly with Salesforce. There are a native connection with Salesforce right now. Select the tables you need and go moving on to the next step and to schedule for a monthly, for a daily, or which interval do you need to produce the data. And with few steps, next finish this wizard, you can connect it to the data on Salesforce. Basically, this is another Lakeflow, and you can access through this link we have here. And after that, I already connected into the Salesforce. So I have access the tables, and those tables are loaded in Unit Catalog or Lakehouse. And now I'm going to prepare this information, ensure security, and to define what I need from batch and what I need in streaming. And look at this. This is pretty cool because we can identify each search from the left side using the Lakeflow Connect. And after that, I can start cleaning, preparing, transformation this information. For example, apply some quality checks here. And here we can join the tables, and you can use this table to inference in a model and to feed a dashboard as well, not only AI BI dashboards, the dashboard solutions on Databricks, but also the external BI tools as well. For example, in this case, we're gonna go to the pipeline and open. Click here directly through the link, and now we can check if your pipeline was not green as well. You can run the pipeline and to check how do the things work. And now we have if it log below, you can check the tables we are working and the kind of transformation is going here. What is this transformation? Look at this. This is the source code. The source code is the transformation code used to make this happen. And let me close. This is the notebook where the transformation is happening. For example, in the first case is commented here, but you can uncomment as well. But what the idea? The idea is to load the data and use it as data. First step, load this data. I creating a table, churning up events. I can also create a constraint. This is quality rules. Which quality rule I can monitor every rule in load time. And as a result of this selection, for example, from a volume, this is a folder, a container in the blob storage, for example, we are going to look for a CSV files in this directory and mapping automatically this column. This is data from event stream. And we already have the option to ingest raw order from ERP. And now they are looking for JSON files. So look at this. I can work with CSV, I can work with JSON, I can work with use data, another JSON for it, and can connect in the databases as well. And let's move back to the pipeline. This is a pipeline, and what I can see here is not only the source code producing this diagram automatically, but you can check as well the table name. If you click here in features, look at it's generate this table. If I'm gonna click here in shiny orders, let's click here on this table and going to unit catalog. In unit catalog, it's possible to check the catalog, the hierarchy, the schema, and the tables created by this pipeline. For example, I have to show this table. I should use a compute, and I can select it and start a serverless compute to run these queries through this table. So by this time, when I start the serverless compute to analyze the information, I'll, in the top, on the left, is it possible to see the available compute to choose? And after pick up one, the available one, we can check table by table. And the table I can see, look at, this is a streaming table. And this streaming table has these columns, and they can check the owner of this column, and they can check as well the last time or the current pipeline update status. If I see refresh details here, they're gonna take me to the pipeline. And so is it possible to see the last completed time they run. So another point here is see the data loaded. We have a sample data with part of the data loaded. So it is possible to see as result of this pipeline, we're gonna keep this table in Databricks Lakehouse. This is a stream table, and I can check the permissions, grant permissions to new users to analyze, and they can see as well the lineage. The lineage, is it possible to see the relationship between the, not only with the volume where the data was read, was produced, the streaming table generated, and the relationship with another tables we do have. So this is the pipeline. This is produced by running this pipeline created by this demonstration. And as you can see here, there are a component, a feature called autoloader. Autoloader or cloud files is a piece of code where you can put in your code. For example, to make with the, as soon as the data land, you can process it. And after that, this is the code for generate this pipeline. You can create a table, and you can, for example, this table, you're gonna name it churn up events. As you can see, churn up events. This is the first table created. And this table gonna read by cloud files. As soon as the data arrives, it processed a CSV file read from this part. After that, we do have another table, churn orders bronze. This churn order bronze is this table. This table was created in Unity catalog and kept it in the catalog, schema, and table name. And JSON files, you're gonna read as well. Another one, raw user data coming from JSON files on this container. And we use it as well, quality rules. For example, user correct schema to ensure it's okay, it's compliant with the data or not. After that, in this pipeline, the second point is enforce quality. So as you can see here, the first step of the flow is to connect and create the data. The second step is gonna transform the data. So I can start here by this table, churn users. I can analyze the churn bronze and select the colors I want to have. For example, this table, churn users. Let's see how this table is. Churn users. We have these columns, and the sample data has the produced data. This is a transformed, a curated data from churn users, and they can check as well the lineage to understand which table this table has a relationship. I can see in the graph mode, and based on this table, I'm gonna transform in another table and gonna materialize in another table. So this is the transformations that this table has for here. And the last step is, before the last step, we have aggregate enjoy data to create machine learning features. We're gonna prepare this data for data science to read this information and work with this information as well. So in this phase, we're gonna create this table and we're gonna create the churn users table as well. And the last one is enriching the Go data with a machine learning model. After that, after load, connect to the source, process this information, create tables, and we're gonna enriching the Go data with machine learning model. At this point, is possible to call MLflow and run a predict churn model. And also you can use the predict churn, this function, gonna call the model, and we're gonna see the model, how to make this model, how to train this model, how to use this model in the next session. After that, you can identify, create a data set, and this data set churn prediction is going to see, let me see, churn prediction, we have a table, this table prepared based on that to understand which customer has potential risk to churn. And you can work with this data preparing. And now your pipeline, you can keep go checking here and analyze this information. I don't know if you do have at this moment some questions in Q&A. If you have some questions, I would like to know if everything is going well. So we have a question here from Adriano. I missed the solution. Christian, uh, we don't have specified a limit for storage in the free dish. What we have is limit, for example, to a compute. For example, we don't have SQL warehouse compute here. You don't have those 2x small. So you also have a limit. For example, you can use only these resources available here. This is what the free edition platform provides to you. This is, these resources are enough to conduct some training, learning, and some test trials, but you don't have, for example, a limit for storage determined here. I don't know where you guys are starting, but I'm gonna check it, for example, step by step again. This should work this way. Churn introduction lake house, and churn introduction lake house, it's only about the explanation, how it works, but starting this folder by the data ingestion, and the data ingestion 01.3 and 01.3 gonna install. The first step is take the compute, install, run, and after that, if you go directly to the churn DLT pipelines, click, and you can run directly from there and run pipeline. Databricks will look for research to process. I can see Marco has some limits achieved. This help of this hands-on is, let me check, is here. They gonna download everything directly into your workspace. If you run this command pip install dbdemos and import this dbdemos, you gonna have everything in your the entire repo into your. But as you can see here, visit the notebooks. This is available to you as access. This is the access you have. let me, okay, go data leaks. Look at this. How do I run as a pipeline? Let's move back. This is the step where we're gonna have access to the resource. And how do we start? As I showed in the beginning. And after that, you can have access to the all. Let me put in the chat for you guys have access, everyone. Let me put it here. And let me close. Go to the pipeline and clicking by turn DLT pipeline. It's gonna go to the pipeline and you can run. Remember, we have clicked in the run pipeline and that's the moment, create your update, waiting for resource, initialize. This is the 5 steps they're gonna have to execute all the instructions we have in the notebook. And you can run cell by cell, but I do recommend you open the Journey DLT pipeline in this notebook 1.3 DLT Journey Python and open the Journey DLT pipeline. And I'm gonna go to the pipeline. And this pipeline you can click in Run Pipeline. No, Milena, it's not common, but Alexander Butti will answer you. Okay, you do have data in AWS S3. The autoloads work to import data from, yes, the autoloader import data from S3. You, just to have an idea, I'm gonna open another environment here to you check how you can connect directly to AWS and you can create, for example, I have some questions here we go. How we can do? We can analyze the information directly from S3. As you can see here in data ingestion, you can create your data sources directly to the sources you have, but you can connect it directly through unit catalog. Has external data. External data, you can create or point out external locations. Look at this. This is all S3s we do have connected here. Since we have connected through external data, Catalog Explorer, if you look at this, you can create external, manual, or by quick start, and you have access to the S3 buckets. And these S3 buckets, you can explore, browse the data if you do have permissions, right? If you don't have permission, you can't see. So this way, for example, I have permissions, I know, so I can list the content of S3 bucket. So this is a connection managed through unit catalog. The method readStream is only to do streaming access. So everything you do need to read in streaming mode, readStream is the method from Spark to keep reading these files. Okay, I do recommend for those who are getting errors, move back to this pipeline and access churn DLT pipeline. You can see it will open. Let me close it is one. It will open this interface. And in this interface, it is possible to run pipeline. This button on the top, on the right. Yes, we do have the instructions to access. I'm gonna put again on the chat for those who lost the connection. This is the instruction. You should go ahead, go to this page, collect this screen in a new notebook, and to take a, compute to process the information. I'm reading at this moment the Q&A session, so if you have questions, Alexander Booth as well is answering, Chris Moon is answering as well, but what I can show you, I will tell and show. We do have connection with Palantir as well. We won't cover on this session, but we do have a way to connect directly to the Palantir as well. So in this first exercise, what we did, we opened this notebook, and this old notebook was imported or created a pipeline. And this pipeline, we did see the distinct sources connected by Lakeflow connected, and Databricks start these transformations, join tables, and load and create a table for model inference. So after that, you're gonna see the autoloader. If you want to understand the how works autoloader, let me check if I have documentation here to share with you guys what is autoloader. Here we go. Let me put in the screen. In this screen, is it possible to see how autoload incrementally process new data as they arrive in the cloud storage? It worked with S3, Azure Data Lake Storage, Google Cloud Storage, and Azure Blob Storage. And you can also use incremental ingestion, and we are using at this moment Lakeflow declarative pipelines. This is what you are seeing here in this screen. This is declarative pipelines. At this moment, you can edit this pipeline and edit this pipeline. Gonna go to this screen. This is the Lakeflow pipeline editor. This is the new way to visualize how your pipeline are going on. As you can see on the left side, you can check not only this code, this is a SQL code, but I can also work with Python user-defined function, UDF. And in the central, I can close to gain more space. I can check every sentence we have in the notebook is going to create some tables, and these tables are below. We can analyze the incrementalization method. For example, if I click here, show me what's happening, and the duration of each table, and how many output records was generated. What is expectation? Expectation is, for example, I define a quality rule to if you have correct schema, allow. If not, don't allow. Here we have another two examples. The ordered validated if the record you are processing has order validated okay, or if not, if it's null, for example, drop it, drop entire line. And or the valid user ID. User ID is another field important to process to avoid keeping bad records in the storage account. So you can drop as well. So another point you can check here, each table processed into this notebook generated a pipeline graph. I can maximize it here and check how my tables are going, or which tables was created. And below, I can check the type of tables, I can check the status, I can check everything is going on with each table. If not, I can move again and hide this panel. This is a pipeline declarative, and we have the possibility to, it's available for comment. You have access to the version history as well. Besides that, we do have how to automate through uh, machine CI/CD process to put in another environment? Is it possible to keep a repository and to deploy it in another environment? So this is the first step. This is the pipeline editor. And when it comes with the autoloader, it means you can work with this pipeline. You can create your expectations. You can create schema evolution and monitor everything in event log. And now you already have a free issue. It means you can, after, try how to work autoloader to process it. This information I'm gonna pass in the chat as well to everyone have access. And now let's move on. Close this, close this. I showed you what is the pipeline and how to run this pipeline. We are in the first step. The first step, let's check in the folder on the left side. On the left side, we are in the pipeline editor, so I can close and move back to the structure you have where the data ingestion folder is the first part of this exercise. So it's pretty important to you guys ensure you can run effectively. And how to get the pipeline editor? Again, let me show you guys because this is important. Go to the Databricks home, click on the logo and this jobs and pipeline. On the left side, jobs and pipeline and ETL pipeline. This is the Lakeflow pipeline editor. And here we can start from the zero, from the scratch, or you can open, for example, configuring for a CI/CD support Databricks asset bundles. It's a tool to automate the generation of this code or looking for the folder where your code is located. In your case, after run the code, the initial code, we load into the workspace and created this folder in the workspace. After run the notebook to import the data, we have created this one, and this one we have all the heap you need to analyze the information you need to run. Okay, let me check if there are more questions. I can help you guys. Click the folder icon on the left, you should see the hash of the demo files. Right, workspace, the name of this folder imported into the workspace, and you can see all the files. For example, we already done this first part in this notebook and accesses the DLT pipeline or the Lakeflow pipeline. Okay, the section could be replaced. Okay, okay. This is the first step, and now we're gonna navigate to the next session. If you can navigate by here. I see only 00 chain introduction. Yes, you can click it, but if not to work it as well, what I do recommend is going to the folder, the workspace, the main hood, and drop, delete entire folder in 3 points. You can move to trash and import again. Just to have an idea, this is the code I use it to load this demo into the environment. So the first one is pipeline, pip install. The second you import demos, and the third one, this is not necessary, but the third one is how to install. After to execute this notebook, you should see the entire folders into the main folder. And 00 is the first one, but you don't have the option to another one. Okay, let's go through the second part of this exercise. The first step, we have created, import the data from Lakeflow Connect. We did see how to process in a pipeline the data and how to make transformation, how to ensure quality rules, to ensure you have only good data, not bad data into the lake house. And now we can go through the data governance. And the data governance, we have specifically notebook 02 UC data governance security sharing. Let's click into And we have, at this time, we do have the need to ensure governance and security for our application for 360 Lakehouse. Look at this. We have two teams, Team A, Team B, and we do need to unify all data assets, not only tables loaded, but files, because we have in the unit catalog. Let me show you guys. I'm gonna duplicate this screen and show you click through catalog. In catalog, we have this catalog here, main, where I installed or them. As you can see, part of this catalog man has a schema dividends retail and has created some tables here. As you can see, there are a table, and this table I can check, for example, details of this table. This is a managed table. It means it's a Delta table managed by Databricks, default, but you can also work with external tables. It means you can connect some files in your S3 and map as external table as well. But this is the most recommended method you indicate to use as delta managed tables because there are more performance. So beside tables, we do have also volumes. Volumes, it's a way to map into your storage account some folders, some containers. And these containers you can go through and analyze directly files. So can be what type of file do you need. In this case, as you can see, the type of file orders, it's maybe for, there are a mapping for users container as well. There are a mapping for events table as well. Let me close here to see better. And it means you have mapping to a source of data into storage account. And this file, you can go through directly for this file, for example, create a table, but you are reading this file, as you can see in details from a MetaStore. It means a manager, but you can also create as well a external volume to point out to your storage location and list every file you have in the S3, for example. And this S3, you can use this file directly from the notebook to analyze information. Each table, as you can see here, this team, data analysts, data science, data engineers, have to have permissions on queries, dashboards, tables, columns, rows, permissions in features such as, for example, data science need permissions on features, on machine learning models, on endpoint and notebooks, but data analysts permits on tables and dashboards to run queries. And the data engineers permits on files, on jobs, and Emily has a central role here to ensure governance, to analyze the central catalog where is located all data assets. In our case, this is all data assets we have to work. And to ensure permissions, cross-team, and let me check the doubts about what I see is present in that location. There are two screens I'm presenting right now. The first screen, I'm gonna showing you catalog. By the menu catalog, you can access the structure of the catalog, the tree where you see all data access. The catalog where I have created my demo, but in your case, you should create in the Workspace catalog. You open the catalog showing this data from the schema and the tables. But at this time of the exercise, we are in the data governance section. Data governance, we have this notebook, and this notebook is what I'm presenting right now. And now I'm checking and explaining to you guys how the permissions work, how to reduce risk with audit logs, and measure impact with lineage. So this is a series of tools to ensure governance and security because we already had loaded these tables. But if you go to the each table, for example, the churn order tables, go to the permissions. As you can see, anyone in the company has access as well. Only the owner of this table has access at this moment to see this table. So the challenge is how to I can share this table to the team of data analysts, of data science, and data engineers. Each one need a specific permission level, and Emily is the people with the whole to identify who need what and to grant these permissions to these guys. And this is possible. It's possible to do with what I say unit catalog. Unit catalog has features to ensure the distribution of this access for each one. For example, data engineers manage and update core datasets. For datasets, read final tables loaded and use feature sets. And this access dynamically masked, anonymized. We're gonna see in this exercise how do works it. And this is possible. Authorize the control list, audit logs, data lineage, and explore, discover some information. Just to have an idea, this is the unit catalog main view. And through the unit catalog main view, is it possible to check details of each element of history? Maybe tables, maybe volumes, maybe models. Look at this. We have a model created by this exercise. We're going to see in the next step. And after that, you can check what is volume. This is the unit catalog. It's a centralized view of your data assets. All of you have. And I encourage you to click on the top, connect, pick up the serverless compute here, and they're gonna start at this moment, a cluster to you, run this code, and we do need to run this out, the cell tree, and wait some seconds. The setup will create everything you need, and meanwhile, is loading here. Please ensure you have clicked and run this cell. What is the idea? Let's explore. Unit catalog works with three layers. First level catalog. You can have many catalogs you want. Schema is an organization of a second level of this organization: catalog, schema, and table. In your case, look at this whole worked. Catalog man, schema, and objects. Models, for example, volumes and tables. This is the instruction based in three layers we do have here. And each catalog can be created by SQL. If you're gonna go to the SQL editor or a notebook, you can create catalog by a command. And you can specify the path. The path is always you have worked to locate this table. For example, a table is here, catalog, schema. This is the address of your table. Not point out to the directly to S3, no, because unit catalog we already have created. If I'm gonna click on the catalog explorer, external data, external location, you're going to create external location. So after create external location, create table based on this external location, you can have access directly for, you only access after the data loaded into the lakehouse your tables directly from here. So your table has table name, schema name, catalog name. So this part of the exercise takes some time to process all the information you need to evaluate this exercise. But at this moment, look at this. When you run this command, select current catalog, they're gonna show you the catalog where you are working at this time. So we don't have selected anyone before because it's running. So you should wait it to run completely. And after that, okay, it's finished. And right now, look at the exercise, change the catalog to the main. In your case, if you follow it, workspace is workspace. In my case, my bad, I selected man because that is appearing main. But in your case, should appear if you follow did you follow the instructions, you should see workspace. So thank you, Milena, for advising me. And the second step is review. We are gonna review, but we already did it, right? This is the review. Please, where we can access, open a new screen, duplicate the screen, catalog, and catalog, you go through the workspace, and here we select. In my case, I have created in man, but in your case, you have created in your workspace catalog. I can check each level of this structure. This is what the proposal of the exercise. Okay, and here is it possible to check the advantage of this platform because you have a complete catalog working with your data, with your data access, not only tables, but files as well. So it's possible to map these files from the S3, for example, and list it there. So there are another comment pretty interesting here is show tables. When you run this command, the cell is going to list the database and the table names you have. It's a pretty simple command based in SQL. You can show all the tables you have. Another example you have here, there are two ways to grant access to the analyst and the other persons. The first way is by code or by UI. In the UI, for example, churn users. If I'm gonna churn users here, and permissions. Grant permissions. I can select all account user, for example, is all I have, and give a privilege. For example, if I'm going to apply tag, this is more for administrative section. Modify, it means add, delete, and modify, update, for example. I can give a privilege. And if I check modify, the unit catalog also recommend grant access use catalog on the main or catalog level and use schema. Well, it means if you want to modify this file, you should start from the top. From the main, I'm going to the permissions and I'm going to grant all users, and these all users can use a catalog. I have the permission, for example, to use schema as well. It means all users I have added on the top. You're gonna see on the below permissions. Here we go. And the tables, you can see permissions. Because why don't have access permission here? Because this is the table level access. The only permissions I gave was use catalog, use schema. But in this exercise, you're gonna run and grant select on table to churn user. This is a group. If you wanna check which groups you have or create your groups in the Databricks, you can go to the your letter on the top, on the right side on top, your letter says identity access. Identity access, you can manage groups, existing groups. Look at this. You have admins and you have users group created by default. And now we're gonna run this command here, giving permissions. Why fail? Because this group does not exist. So it means why we got this error here? Because I'm looking for analysts and we don't have analysts. This is the principle. So the way to fix it was add a new group analyst. So now you have a principal and you can look at this. I have one member in admins, one have users. This is a free edition and use it for personal use, right? So you're not going to have more users here, only we. And now we can check if you have some data engineers. So you have to have also data engineers and new data engineers group. This is to show you guys how you can start distributing access to your analysts on specific tables. You have shared user table, you have shared app events, you have shared yards. Another topic important to see here is this button, diagnose error. The artificial intelligence of Databricks generate instructions. So account console, admin privilege required, and show. Let me see if you can choose copy and paste here. There are SQL commands to show existing principles. If you have access, okay, you should keep this. If you have access to see, the solution gonna provide us the uh, the principles. I don't have access at the moment to run this command on this workspace, but what is important to know, you can do by this interface directly from the catalog on the object. For example, I don't have another user here, but I can check here if I have created the group analyst. So all people present in the analyst group has the privilege to see this table. I don't have permissions, could not find principal name analyst. It was not created before, but you can aggregate your method. And I can show you in another environment just to have an idea what I'm saying to you. So I'm gonna access my catalog here. And this catalog here, we have, for example, this catalog. I'm going to permissions, and the permission, for example, I have a principal create several analysts here, and I can use schema, select and modify, and I can confirm this is the way, and you can check the permissions on each table. So I have more 5 minutes here, I think. Please, Sophia, help me to track my
Yeah,
time because
that is correct.
perfect. Moving on, again, I'm the second part. This is data governance session. And this data governance session is showing you guys how to using the commands to ensure security. And I did show you how to grant permissions directly to the object schemas and catalog. And drop table users protect. You can drop your table and you can create the table from a query. For example, this table does not exist yet, right? because that we are not working. But I can comment here and create this table. You are creating a table from another table. And we're gonna create right now some functions here. So I have created this table, journey users, and this table, I'm gonna create a function to mask. There are a way to mask it not only by code. For example, if you go into the table, overview the table, look at this, you have a column masking, and if you have permission, you can add a mask function. But how create this mask function? First step, if you are part of this group, you are not part of this group, please don't show. Each command we have run here permit you to, when I select this table, the list, but the email was not was rejected, right? So this is a way to create a mask function and to apply insert columns to ensure PII compliant. And another point here, I'm going to pass the word to the Sultan in 3 minutes, but you can go and check everything you have on this notebook. For example, I did show you how to connect to S3 to map a location to using unit catalog. You can check lineage as well. You can check audit log. And also, if you are a Databricks user but don't have access to unit catalog already, you can use it as demo. The same way you have deployed the demo, but you change the name of the demo. And you can share with external organizations as well through an open source protocol called Delta Sharing. To get more information about about unit catalog, you can go through unitcatalog.io, and here it's possible to see unit catalog is part of the open source project right now. I'm going to put in the chat, and you can check more information how to ensure security, how to ensure central governance into your workload with Databricks. So this is what I have for this moment. It's up to you, Sultan.
Nice. Thanks, Moses. I'm gonna share my screen.
Yes, you can see right now.
Perfect. Thanks. Okay. Hi, everyone. This is Sultan. I'm a solutions architect logging in from London, and happy to be here today to demo some of the exciting features we have around ML and AI. So I think the first part of the workshop was mostly focused on data engineering. How can we grab, ingest, and put data on Databricks? Now the data is there, being hosted in Medallion architecture. We have the necessary access permissions being put in. We can try to implement some AI features. So the first thing that we have to think about when working on a data science project is what kind of business objective we are trying to achieve. And in this particular scenario today, we're going to use the data that we have in order to build a propensity modeling using traditional ML models in order to predict the likelihood of a customer to churn. And if the time permits, we're going to try to see how we can take this further and try to implement a generative AI approach where we're going to build an agent in order to try to generate personalized messaging, which could be sent to those customers who are likely to be trained. From lab setup, we're gonna look at the fourth subfolder in the repository, which is called Data Science and ML. If you go there, you're gonna have 3 notebooks, which we are gonna try to cover today. The first one is around setting up AutoML churn prediction. Then we're gonna review the notebook which is being generated by AutoML, and then we're gonna see how we're gonna run inference on the developed model. So the first part of the notebook itself is just like explaining why we do need to do ML, and the challenge which we see working with customers is like they do a lot of proof of concepts when it comes to ML, but they are not able to make it to production. So around 90% of the projects being built by data science teams that are not being productionized due to scalability, security, cost, and many different reasons. And this is the beauty of Databricks. I mean, it streamlines the process for teams to build data science products. Why? Because the data is being hosted in the same place where the data science teams are building their models. They will be able to do their EDA, model training, and model deployment and model monitoring in one centralized place. And they could have support from data engineers and data analysts as well. So for the scenario today, let's think of a persona here. Mark is data scientist, needs a data and ML platform in order to develop an ML project. And the first step when we need to do ML is around building the data pipeline to put the data to Databricks. And I think this was covered in the first part of the lab. The second part is when the data scientist has access to the data, and now we need to do some EDA or explorative data analysis in order to pinpoint some correlations, relationships in the data that can help us in exploring and identifying thoughts, which could help us in driving the ML project further. And then after we do the EDA, we can think of the interesting features which can be used to train the model. We train the model, we deploy the model, and then we monitor the model. And when it comes to deployment, of course, we have 2 possible options. The first one to deploy batch, where we store the predictions and we query it at the time that we want. Or if we want more real-time monitoring, real-time inference, we can also deploy it using model serving, where we have like a real-time endpoint which we can invoke and integrate it to our applications. So AutoML, you can think of AutoML as like out-of-the-box feature where you give it the data set that you want. You tell it which target variable you are trying to predict, and it will create an experiment for you, and it will recommend the best model to use. So the first part of the notebook is simply installing the libraries that we will be using on the notebook, whether it's MLflow or Databricks Feature Store. And then we're gonna load the data set which we're gonna work with, which is called churn features. And if you remember from the DLT pipeline that we shared before, this is one of the tables that we built, and we said that this table we're gonna use it for ML training. And if we explore the data set so quickly, we could see the features that we have, which is around what country is the user from, gender, age group. And if you see, we have a target variable here is called churn, which is 1 or 0. So we're talking about binary classification machine learning task here. So after we loaded the data set that we want to work with, as I said, the first step is to conduct our EDA. And with EDA, we're going to use a library called Seaborn. And what's nice about Seaborn, you give it the variables which you are interested in analyzing, and it will pinpoint or like draw for you several visuals where you could have some insights. For example, if we see from these visuals we have seen that, for example, there is strong positive linear relationship between order count and total amount. We could see, for example, the distributions of some variables. We can see that, for example, total amount is right skewed. So after we could of course go more in depth and study the features more, but for the sake of this exercise, we just like wanted to show you how you can conduct EDA. And then after we identified the features we want, or if we wanted to create more features as well, we could also do that. And then it's the time for us to take these features and potentially create a feature store. And the question that you might ask yourselves here, why do I need to create feature store? And this is the question which we receive from customers. You can think of feature store as a table, centralized table, which could be used by various data science teams, where these features could be help for your reusability and reproducibility of these features. So each time I want to work on new ML project, I don't need to go again and create the same features. So it's just like I can pick up from the feature store the features I want and use it in my new machine learning project. And for you to create a feature store, you simply have to use the feature store client API. And you simply you have to do two calls. The first call is to create the table, in the feature store. And feature store, as I said earlier, is simply a delta table, which should have a primary key. And this primary key should be unique, constrained, and shouldn't have null values. In this case, we are saying that the primary key for this feature store is going to be user ID. And then you give a description, what this feature store table is going to be about. And then after you create the feature table, you have to write to this feature table. And we'll simply write the churn features data set here that we explored before into this feature store table. So at this stage, we define the feature store table and we wrote to this feature store table. And our feature store table should be ready. And you could, of course, display the features identified in this feature store table. So we conducted our EDA, we identified the features, we created the feature store. And now we are at a stage in our project where we could start experimenting and spiking machine learning, training machine learning models. And as I said before, we're going to use AutoML, which is a capability we have in Databricks. It lets you explore or experiment different models, and it will recommend for you the best model based on a metric you choose. That this is a model that you could take it, fine-tune it further probably, and take it to production. So it will take the time for you to experiment different models. And for you to create a AutoML experiment, you simply have to go. You could do it in two ways. The first way is to do it through the user interface, where you go to the experiment section here, and you simply identify the use case that you are working with, whether it's regression, classification, or forecasting. And when you identify the use case that you are working with, you give it the data set, the target data set, which is going to be the feature store table we created. And then you identify the target variable, what we are predicting. In this case, we are predicting the churn column. And this is going to be the target variable that we're going to work with. So this is if you want to create it through the user interface. And we also have the option, because I know that data scientists sometimes, or most of the times, might prefer to do it through code. And this is where you could do it through the Python SDK. And through Python SDK, you could simply call the AutoML package. And within AutoML package, you call the instance that you want. In this case, we are classifying. So you call AutoML.classify. If you are doing forecasting, for example, time series forecasting, you do AutoML.forecast. And you could go and check the AutoML documentation for that. And so we define or we initiate the model that we're going to work with AutoML. In this case, we are talking about classification task. You define the experiment name, the data set that we are working with, and the target column. The same stuff which I mentioned before that we wanted to define in the user interface. In this case, we are defining it through code. And so with the target column is going to be churn. You could define the timeout minutes for it not to run forever, for example. And then you create the AutoML experiment. This would take some time to run. After it runs, as I said, it will experiment through different ML algorithms, and it will recommend for you the best model to use. So when the experiment finishes, I think three components you should be able to work with as data scientist. You should have a data exploration notebook, which goes, for example, it also conducts EDA for you, and it will tell you insights on correlations and interesting relationships in the data. And then it would tell you as well what models it was experiment against, and this is the model that you should go with. And if we go to the next notebook here, this is the AutoML generated notebook. So this is generated by AutoML. And this notebook, which shows this notebook, but because this notebook includes the best performing model. So you take this notebook, which includes the best performing model. I'm sure it's not gonna be the final model that you're gonna deploy, but it's, I think, the first good step for you towards getting towards the final deployed model. So you take this notebook and you further tune, spike, and improve on it. And yeah, as I said, Databricks AutoMLs will try many models, and it will generate notebooks containing the code used to build each model. And then we select the notebook from the best run. So we see which best run was achieved based on the performance metric that we are interested in. And we use this notebook and we are viewing it now. In this case, the best model which was recommended by AutoML, it's the light GBM model, which is a gradient boosting framework model that uses the tree-based learning. And so if we go through the notebook, we see like how the notebook was, how the model was trained from scratch. First, they loaded the data. So the AutoML, it loads the data. And we see the data which was loaded here is the same data that we reviewed before. It's around the churn features. And you could see that it has the churn target variable if it's 1 or 0. And probably here it's gonna go a bit data science heavy, where we have to think of the ways to prepare the data for them to the ML training. So we're gonna select the columns that we were interested in from this table. And then the first step, because as we know, like machine learning algorithms expect data to be numeric. So we cannot work with dates and we cannot work with string categorical data types. So we have to think of ways of converting this data into numeric format, which can be fed to the ML algorithm. And the first step that we are doing here, we are creating a date-time preprocessor, which simply it will take a column which has a date format, and it will change it into hours of the day, hours since beginning of the week, hours since beginning of the month, etc. Or you simply, to make it more simple, you take a date time and you convert it into day, month, year. This is, I think, the most easiest way to do it when working with date. And then you create this date time transformer. And the second one is around Boolean columns. So if you have columns which has true or false values, you also need to convert it to numbers. And when it comes also to numeric columns, also we need to think of way if these numeric columns has missing values, for example, because we cannot feed a data set to a machine learning model which is not distributed properly. And for this exercise, for example, we take these numeric features and we could impute the missing values in these columns with either median or mean. And in this case, we are choosing mean. And we could think also of standardizing this data. And for this piece of exercise, we are using the standard scaler, which simply tries to make the data points more as normal distributed. For categorical columns as well, we are using the one-hot encoder, which simply converts the categories into 1-0s columns. And at the end, we just need like to combine all these transformers we created, one for the date time, one for the Booleans, one for the numerical, and one for the categorical. And then you combine it together as one like preprocessor that we could use using column transformer. So we worked with the data. Then the next step is to do the train test split. You split your data for train and test. You use the training data set to train the model and the test data set to evaluate the performance of the model. They used here the gradient boosting classifier. And then we could use MLflow to log this model. So MLflow is our open source library, which helps in model deployment, traceability, and packaging as well. So you use MLflow to register the model. And then after we register the model, we could load the model to be used for inference at later stage. And yep, in this piece of code here, we are using the model to fit it on the training data set. And then we are loading the model. We are adding the model to MLflow. And then we are evaluating using our test data set. Another piece of exercise that we also could do is to do hyperparameter tuning, where we define a set of parameters, and we use the library to search the parameter space and select the best hyperparameters combinations that could boost model performance further. And here's like a visual of what we achieved so far. So we built the pipeline using the column selector for each of the different data types we have, whether it's timestamp, Boolean, numerical, and categorical. And we highlighted what we did for each data type. Also, another thing that we can think of also while doing our machine learning training is to look at feature importance. So all these features we have in this exercise, probably we have around, I don't know, 10, 15 features, but in real life examples, we might end up having hundreds of features. And a struggle for data science is like, what are the features which we should keep and what are the features which we could disregard? And for this particular exercise, we could use CHAP, feature importance, which will simply, if I run CHAP, it will tell me which features are driving the model predictions more than others. In this example, we could see, for example, gender, age group, and event count and country are the most influential variables which are driving the model predictions. We could also evaluate the model. To evaluate the model, there are different methods which we can think of. Confusion matrix, which helps me to look at precision, recall, ROC, etc. So it depends on the business objective, what we are trying to achieve, what we are trying to maximize here. We could choose a appropriate performance metric, which we could report back on it to the business. So this is that, I think, as I said, this is notebook generated by AutoML. This is the first good step for data scientists. I'm sure that if I want to take this to deployment, I have to further work on it and further investigate the model performance, improve it, and then when I'm good with it, I'm ready to deploy this model. And when deploying the model, we have two approaches: either batch, where we generate model predictions, we store it, and we keep it there. When we use it, we query it, just for faster querying. If I'm talking about real-time inference, I need to deploy this model using model serving, create an endpoint, and invoke this endpoint for low latency predictions. So if we want to deploy the model for predictions using the batch inference, I load the model using ML Flow, and then I create this method using mlflow.pyfunction.sparkudf, which will simply take the Spark session that we are using in this case, and it will take the model that we deployed before from the AutoML models. And here I'm calling the model which has a production alias, and then I'm gonna give it the prediction, the data frame which includes the features, and I'm gonna ask it to predict. And here I'm asking it to predict, and then I have the table which includes the churn predictions. If we go to the end, you're gonna have the churn prediction column, which either 1 or 0. 1 indicates that this customer is likely to churn, 0, they're not gonna churn. The same way, if people want to use, for example, pandas rather than Spark, because we know that Spark is used for when the data set is big. If we're talking about small data set, we could simply use pandas. And for this, we load the model from ML Flow, and then we use data frames also using Spark, and then we do the predictions as well. So when we're talking about batch inference, you could either do with Spark or with pandas. So if we're talking about real-time inference, as I said, you have to use model serving. You have to create an endpoint and use this endpoint to generate predictions. And when creating a real-time endpoint, you could either do it through the user interface, or you could do it through Python SDK. It also depends on your preference. In this example here, we could do it through the user interface, where you create endpoint and use it for predictions. Next, I'm going to stop here to see if there are any questions. Okay, I think we are good. All questions are being answered properly.
Sultan, we are seeing another screen of you, the general settings screen. Just so you know.
Sorry, what was the question?
No question. Just so you know, you are seeing our general
yeah.
screen settings. Okay.
Okay, nice. Okay, I'm just checking if there's any questions in that chat. Nice. I think this takes us to the end part of the traditional ML, where we trained the model, and then we deployed it. We explored the option to deploy using batch inference, and the other option is to deploy using real-time inference. And as I said, if we are talking about real-time inference, you have to create an endpoint and invoke this endpoint to do the predictions. And at the same time, if you see here, where is it? You should be able to see the predictions generated by the model. Cool. So yeah, I think let's go to the fifth part of this workshop, where we're gonna try to cover a bit about generative AI. So I think what we explored so far is around predictive modeling. So we used historical customers' data, and we try to develop a model which estimates the likelihood of a customer to churn. What if we want to take this further and we want to do some prescriptive analytics, where we want to use, like, for example, LLMs in order to generate a personalized messaging which could be sent for those customers who are likely to churn. And in this case, we are talking about another persona, which was Lisa, a generative AI engineer. and they want to leverage Databricks to build a prescriptive system aimed at reducing customer churn by harnessing the data, by harnessing the customer's data, which could be fetched from a database, and the churn propensity that we generated through traditional ML. So Lisa wants to develop an agent, which everyone is talking about agents these days, which can help minimize the time that account manager spend crafting like personalized messaging. And more specifically, Lisa wants this agent to do these three things. First, the agent has to check if the customer is likely to churn, yes or no. Second, if the customer is likely to churn, we have to check the recent order information. And third, we have, based on the information that we have about this customer, we have to generate a custom tailored message, which we could send to this customer in order not to lose them and be churned. So this is like the three main objectives of the agents that we are trying to build here. And in this case, what's good about Databricks, you could create functions that could this agent use as tools and register these functions under the Unity catalog. So within the Unity catalog, you can not only register tables and have the lineage of these tables, you could also register models, and you could register functions as well, which allows you like to have proper access controls, lineage, and discovery all under Unity catalog. So the first function that needs to be created in this scenario is the function to look if the customer is gonna churn, yes or no. And in this scenario, we are calling this function the churn predictor. And the only input variable that this function needs, we need to have the customer ID. And we have the customer ID. We then gonna go to AI query. AI query is one of our built-in AI functions that we have as Databricks, which I highly encourage you to go and explore it. We have AI query, we have AI classify, AI summarize, AI detect sentiment. So all that's built-in AI functions which you could use on your work without have to worry about the built-in or the infrastructure of these functions. AI query is one of these built-in functions which simply needs an endpoint, which could be created out of ML model or LLM. And then you give it the requests and ask this query, ask this AI query function to query the endpoint and then give us the prediction. So this is the endpoint that we created before from our machine learning model, and then we are querying it in this scenario to get the predictions. And for us to get the prediction, we have to give it the features. And the features, it's around ID, gender, platform. We saw these features before. And then the AI query will query the endpoint and will give us the prediction if this customer will churn, yes or no. It's either 1 or 0. And here, for example, we are just doing some mapping. If it's 0, the customer will not gonna be at risk. If it's 1, the customer is gonna be at risk of churning. And we are testing this function, which is called churn predictor. We give it a user ID, and then it's giving us the prediction. For example, this customer is at risk. The second function that we want, because I think we said that 3 things. The first thing is determining if the customer will churn. It's gonna churn. Second, we need to find like relevant information about this customer. And for this, you can think of it like fetching the database for whatever information we need about this customer. And in this case, we need, for example, the first name, when they placed their order date, how many items they requested, etc. And then you could give a description about this function, what this function is doing in a nutshell, and then some other data manipulation that you want to do, and it will simply give these data for you. So it's fetching the database to give you this particular customer, what's the channel communication, where they are from, what's their gender, how much they ordered, last order date, etc. So, and this takes us to the second task. So we achieved the first, we achieved the second, and now It's the fun part where I have this information about the customer. What can I do to let this customer not churn? And this is, we can think of creating personalized outreach messaging for the customers using LLMs. And probably, I think if people worked on LLMs here before, the first approach that we take when working with LLMs is to simply do prompt engineering. If prompt engineering doesn't work, we can go to RAG. If RAG doesn't work, we can go for fine tuning. But for this exercise, we are just like talking about simple prompt engineering. And with prompt engineering, I'm just like prompting the LLM to do what I want. And I'm giving it some examples to know what success looks like. And for this prompt, yeah, we are telling the LLM, you need to write copy of contemporary apparel retailer, nothing further. We are giving access, we're giving like description of the data points which are being given to the LLM. And then these are the rules that you should follow for you to create a copy. You could further elaborate on these rules. You could give it a few examples to learn from, and you could version these prompts that you are working with using MLflow. So we have a capability which is called prompt registry, where you can register every prompt and then see how each prompt is performing against the data. And then we call another function, which is called this time generate marketing copy. And this function will take all the inputs about the customers, including their churn status, and it will generate a response to the customer. Remember, you don't need to do any further or like any advanced coding to compile this prompt to the LLM. You could simply use the AI query function. And with the AI query function, you simply specify the LLM that you want to use. In this case, we are using Llama. You might say, I want to use ChatGPT, I want to use Claude, whatever. As long as the LLM is available, you could simply let the AI query to use the LLM that you want. And then you concat or you do prompt augmentation in this scenario, where you concat the prompt with the customer details, and this AI query call will simply follow this prompt to create the personalized messaging that you have to send the customer. This is an example. You are using this function, the generate marketing copy. And this is the message which is being generated by the LLM, which could be sent to the customer. Nice. I think this takes us to the last thing that we could do with generative AI, which simply we created the agent using the functions. What's next? We should think about deploying this model the same way we deployed our ML model. We could also think about deploying our agent. And with deploying agents in Databricks is like, as someone who has worked like on developing agents from scratch and deploying it, I think Databricks interface is very, very simple and friendly when it comes to deploying agents. And we could simply access the Databricks playground, which I think if I duplicate my screen here, and if you go to the playground here, you would be able to see the Databricks playground, which have access to different models, ChatGPT, Claude, Meta. I'm not sure if all of them will be available here within the free edition, but you select the model that you want to work with. You could do system prompt and you start interacting with this model. Not only this, you could also include tools that could be augmented with this model. You could augment it with UC function, for example, the functions that we worked in before. You could integrate it here. You could add your vector search. If you are building a RAG a tool, you need a vector search. So you create embeddings and you create vector search index and added this to be used with LLM. And of course, if you want to do MCP servers, also this can be implemented as well. And then you could test the product that you are building in the user interface playground. And you have here the function for evaluation, which includes AI judge in order to judge the predictions of, or not the prediction, the generation of the model. And it also supports synthetic generation, question generation as well. So if we go back to our exercise here, we have to simply go to the playground, select the model that we want to use, whether it's Llama or Cloud or ChatGPT, add the functions that we created before, which are 3 functions: one to choose to identify the prediction, one function to fetch customers' data, and one function which uses the AI query to generate a customer message. So you add these 3 functions, and using the LLM, you would be able to build your agent. And when you do this agent, you could simply do export, and when you export it, it will create a notebook for you, which is called tool agent, tool calling agent, which will simplify the tools that you have to follow to deploy this agent. And when you deploy this agent, you could simply call it or invoke it to generate content that you want. So what's next? I think we can think about agent evaluation. We can think about further agent deployment using Databricks apps. If you want to share this agent with other people who don't have access to the Databricks workspace itself, so you can deploy it using Databricks apps and share it with them, and probably orchestrate this agent within an end-to-end workflow that you are working on. Nice. I think that this takes us to the end of the tutorial on ML and generative AI. I hope you like it. And yeah, any questions, feel free to dump it in the chat.
All right, let's kick off our last session of the day. Thanks everyone for staying on for this workshop, and we'll pop up a poll towards the end, and we would love your feedback to understand what worked, what didn't, anything that you'd like to see in the next one. So please do complete that for us, and thanks again for joining.
Okay, Sophia, let's go. Welcome back. I hope you grabbed some coffee or water. Now we have ready to dive into in the next demo. So before to dive into in this demo, I'm gonna move back to the 00 notebook. Just to remember, we are talking about a lakehouse platform for collect data from distinct sources and manage our workloads into in a simply and unified platform with unified governance, unifying the storage account, and bringing intelligence to this data, right? So as you can see here, each workload of Databricks is unified in a catalog and a strategy of distributed information. And just review some steps. Start with data engineering. After that, we talked about a little unified governance, and after that, BI and data warehousing. And now we're gonna talk about this part. You have heard about the machine learning data science and generative AI by Sultan. And now we're gonna deep dive into BI and data warehousing. Our data sites are now properly ingested, and we applied security checks on that, permissions, distributed access to the business teams, to data engineers, to data science. We already have run a model and generated an inference table based on this model as a result of this model. And now we're gonna make some analysis on this data. And for that, we do have AI BI on Databricks. And here is important, Databricks Lakehouse is the way you can load your files and you can use it for BI, for data warehousing. You don't have to move your data external from Databricks. You just have to use your serverless warehouse to serve this information to the enterprise reporting, to Databricks, real-time application. We are running in a free edition. Free edition environment. Let me go ahead to Databricks. As you can see here, what's new? Recently, Databricks made public preview embedding dashboards for external users. So it means you can develop your dashboards on Databricks and serving externally in applications in outside Databricks. And there are a lot of things we are working here. For example, filter bar and another terms for visualization. One of these visualization is Databricks One we're going to cover by the end of this exercise. But we're talking about SQL, right? And with the comings to SQL, you come up to SQL editor where we can run queries. Queries based in SQL. And for that, you're going to use a SQL Serverless Compute. From the left side, you're going to through to the SQL House and SQL House. As you can see, by the Databricks Free Edition, you have a serverless start warehouse, a serverless type, and you don't have permission to create anymore because this is a free dish and this is enough to make some requests. But just so you know, if you have your environment, a Databricks subscription, and go to the SQL house and want to create a SQL house to process your data, to make some queries using dashboard, using external tools, you can create a SQL house, giving a name, for example, SQL Workshop, and you can pick up one of the cluster size from the smallest to the largest, and this first, for example, and determine the auto stop after 10 minutes. The interval minimal is 5 minutes. It means if you inactive for 5 minutes, they stop the cluster to not charge you. And you can also scale up if you have, for example, a behavior of 1,000 people in 7 months, 10,000 people, 1,000 domators. You can pick up the auto scaling. And there are three types of compute here for SQL, for the warehouse, but serverless is the most common, and you're gonna create, and look at this. After few seconds, you have a compute, a cluster to make your queries. Create queries, run queries, to use the ABI dashboard to send alerts. This compute SQL house where we can select for you and monitoring as well. You can check by monitoring tab all the information the query sent to this cluster and monitoring, for example, what is going on this compute, when it's necessary to scale for another computer, the total query count we have, the peak, the queued peak, and as well, for example, in this case, I can monitor, for example, this dashboard. This is a query run from a dashboard, and I can see the details of this query. How many files, how many space was spent on this query, and to know how many cost it query as well. In our case, moving back to the notebook, we do have some information. So I can access by here on the folder on the left side in Workspace. We can go through the AIBI Data Warehouse. AIBI Data Warehouse, there are two sessions. The first notebook is talk to you. How works the SQL for Data Warehouse? And the second one, we're gonna talk about the Genie. Genie is as I can say, I usually to say a copilot for Databricks. So where we can ask questions in natural language and get your response. Is a text to SQL. Is you write, you type in your question and receive your answers. So in this case, keeping the idea of this demonstration of this workshop, Alice is a BI analyst. Alice just need to see your information. So ensure the information was loaded in the Lakehouse, was ensured for the unit catalog through permissions. And now, is it possible to see how this information works. If you're going to talk about BI engines, we have benchmarks from the market. For example, in this case, we have 100 terabytes TPC, TS, which evaluated price, the relationship between price and performance. And as you can see, Databricks SQL Spot on demand is the best option so far compared with another near another SQL warehouse technology in the cloud. So it means it has a good performance, 12,000 better and more cheaper, right? So, but I demonstrate to you how to create a SQL warehouse. A SQL warehouse, once more, is a compute, with intelligence, with telemetry to understand, to run your queries effectively in a performance way. And so it's pretty simple to create in this environment you have today. You don't have permission to create any SQL warehouse anymore. But the good news is you have already created this SQL warehouse. And if you go click in the serverless SQL warehouse, you can check some information. For example, the configuration applied here, but the connection details. This is pretty important to you understand how to connect, make a bridge before with Lakehouse, with, for example, Power BI, Tableau, DBT, Python, and other tools external from the Lakehouse. And here we can get the connections to these tools and use Databricks SQL to serve your Lakehouse data to another applications. And in monitoring, you can see every query you did, it will appear here. And this is important to see each query has a history, a profile, where you can check the plan, the query plan to find the result. So this is pretty important to understand if it's a performatic query, if everything is going well, where the effort to get the results. You can change it to understand each step of the execution of this query. This is intelligence provided by serverless starter warehouse. And a serverless compute, it means it's managed by Databricks. It's going up in few seconds, 3 seconds, no more. And stop it. As you can see, is stopped. But if you go to the SQL editor, in the SQL editor, we do have a catalog right there, and I can query some tables. So for example, I already have some tables there, and I want to like to analyze the churn feature. So I'm going to move to the right and make a select. At this time, ask me to select a SQL warehouse. Start a touching run. At this moment, the compute is going up, is starting, and in few seconds, I have the answer of my question. I can use my query. So the compute, where is the compute is going up and answer my question. And here I can follow up the way. And now, if I'm going to I'm here, SQL editor, and I'm going to the SQL warehouse. It was stopped, right? But now it's running. Few seconds. I'm going through, stop again, just to see once more, and it's stopped. But when the user open your dashboard in Databricks or outside Databricks, point out to this SQL warehouse, immediately this compute start and answer the question. And in few seconds, you have the information you need This is important because ensure you don't have to pay for the time you want to use. So now I have my question, and you have few times spent here because there are cache. So they read cache and you don't miss anything. This is part what I'm showing here. And you create a SQL warehouse and you use it to create your first query. In this case, we already done. So as I demonstrate to you, I'm going to the SQL editor, and I can save as well. This double click here, first query, or I can use the artificial intelligence, the AI, the clicking the star and ask for create a name. So there are a lot of points here to you understand if you can save as a query and use it as query after. If you can export, you can explore more about the items you have available here. For example, if I wanna filter for USA, I'm going to the filter, display data, only USA, and automatically apply a filter on this data. Let me open more to have an idea and hide performance, apply a filter. And you can add a filter, you can use the artificial intelligence to look up some information there in this data set. This is SQL editor. So you explore data, create your queries, and work with your data. If you want, there are another options there in edit code with assistant. If you're going to put a slash, this is the options provided by AI, verify, optimize, fix query, verify, for example. If you make an order to verify, you can see accept, they organize. This is a simple query, right? But imagine you work with a big query, a lot of lines. The artificial intelligence can organize for you. So you can also schedule as a recurrent query to run from the side. So if you go to the schedule, you can define run daily, run every month, every hour, every minute, and define the time zone, and always pick up the SQL warehouse available because you could have more than one, right? For example, I have customers who each department has one because they don't want to pay for a general SQL warehouse. So you can make a strategy to serve your data through SQL warehouse by business area or not. You can use a big SQL query to serve uh, a big amount of users. It's up to you. It's pretty useful, this feature here. So we have created some query, we have asked, but there are another feature I want to explore here. If you click on the star, this is star on the top, this is Databricks Assistant. And in Databricks Assistant, you're gonna ask a question. Help me to find only records with more than 5 events. So if you are talking with your data, this is not Gene yet, but the assistant, we're gonna create a query to you, and you click on the arrow and execute, and now think for you. It's pretty useful to use artificial intelligence to help you save some time and find some behaviors on your data, discover some insights there. So this is a easy example how you can use the SQL editor to create your query and run. So there are another points based in this workshop, and I'm going to show you This is the typical churn dashboard. Databricks has a solution to create dashboard. It means you don't have to go to the outside Databricks to use specifically a BI tool. You can use the solution dashboard of Databricks. If you can click here, so you go to this screen, and this screen you can close it there and check this dashboard. This dashboard show us the customer share, the unified view of customer share. What we can see here, first step, the name. I can rename, double click, rename. I can also change the serverless warehouse, because to handle this dashboard, Databricks use a serverless warehouse compute. So you can customize your default warehouse in case you have more than one. You can share with external people. For example, here you can share with groups. It's most recommended to share a group, or you can share a specific people and choose some permissions. Who can edit, who can run, who can view. And after that, you can copy the link and send. And also, after publish, you can embed this dashboard externally. But now, just to understand this structure, here, if you click on this topic, you're gonna see the data set where the data is coming from the journey customer channel. So if you see on the top, we have data and new page. If you click on the data, there are many data sets here. These data sets is used for the dashboards. So the first one is a query. This query, you can go here and see what is being done here for this query. And now we can also add some parameters, create custom calculations, but this is a data set. We have another data set, and this data set, this is this information. And we do have the customer channel universal. This is exactly what we have in the page we are working. In this page, if you double click here, you can change, and you can add some pages as well. For example, detailed, and to create a new graph, I'm going to show you. If you look at these options we do have on below part of the screen, add a visualization. When you click on, you have the option to create a visualization. And the best part of this visualization is you have the option to ask the assistant to create a chart using the artificial intelligence to help you guys create your visualization type. And also provide some options. The model understand is good to you, can be good. For example, the total MRR is an internal KPI, and you can accept and generate a card. And you can move ahead and start, for example, another kind of visualization, or by, for example, no, let me ask something more about this data set. This data set, you're going to talk about the retail, right? Churn, customers. If you starting asking something, they gonna look for the information, the correspondence you have. But before creating, let's understand better the data we have here. So in the general, we do have the customer past channel, and this indicator show us, if you go into the notebook, you can see part of this information here. Below, you do have more information and understand how the data is structured. But let me check. Subscription based on internet service. There are type of telephone, and churn by population type, by gender, for example, and MRR over time. So what you can see here, you can also customize this chart and, for example, start in change the visualization, and you have the option to download it. You have the option to clone it. You have several options to work with distinctive visualization. In this case, we are using an area chart, but you can also, depending on your type of visualization, you can pick up another one. And now it's good. Just see some adjustments here. And now I'm ready to publish. When I publish this data, there are two important information here. The first information you have is you want to embed the credentials. It means all the people you have to share this information use your permissions to execute this query. Or if you don't embed credentials, it means each user one gonna see your dashboard needs to have permissions defined on the catalog, on the table behind these queries. So it's up to you. It's two options. You should decide what is good and depending of the nature of the information. Notify the users. And here we do have enable Genie. If I'm going to enable Genie and publishing, and now at the second, after to publishing, they ask, who is the people you want to share this information? I can share this dashboard to the, for example, our users, but only to visualize. And I'm gonna add, close, and see. At this moment is enabled a view published button, and now is it possible to see how our dashboard are. And this dashboard, I can check, analyze this information, evaluate the information, but I do have the option to ask Genie, a chatbot where you can ask questions in natural language and ask it, for example, what's the total monthly recurring revenue? MRR. And Genie start generating a query and get this number. As you can see, it's the same, right? And you can go ahead asking more by payment method. For example, started asking any more and generating include some graphics here to understand the behavior. You can provide a feedback if you need some adjustment or if it's okay, and you can keep asking. Genie has the intelligence to understand all he knows about your data based on metadata, based on past queries, based on behavior had on the platform to calculate. And as you can see here, execute and create a query to use the data. So this is Genie is integrated with your dashboard. If you want to create a separated space to analyze your data, yes, you can do it, and we're gonna show you in few minutes. But AI BI dashboards, there are no licensing costs. It's not, you don't pay for user, for example. This is the big difference from other visualization tools you do have in the marketplace. You only pay for the SQL house attached to run this process. For example, if I'm gonna to edit this draft again, you only pay for the time you spent on the serverless start compute, and you can distribute to every company, to everyone in the company, and show them, share with groups, share with the users, and use this information. And the best part is you have artificial intelligence enabled, generated insights on this information. We are working in the next versions. For example, Databricks has a lot of examples, demos. If you go to your search and look at for Databricks Demo Center, you are gonna find some interest points. For example, explore all demos. And explore all demos, there are a lot of demos here. And part of this demo, for example, data warehouse. In data warehouse, there are a lot of demos you can try on, including in this free edition environment. And part of these demos, we have AI BI dashboards. AI BI dashboards, you have examples. For example, these dashboards you can use on this platform to understand. There are videos, there are tutorials, there are another part on demand tutorial, for example, customer support review. You can set up this dashboard, only you have to point out and you have access. And it's important to know the solution for visualization you can access by the left side on the menu, SQL dashboards. All the dashboards is going to be here. And as you can see, we do have 3 dashboards here. And example for retail supply chain. If you click on, you can import this dashboard to your environment to understand how the queries was made. And at the moment you create from a SQL, from a dataset, and look at this. You can upload a file from your computer, and from your computer, starting the same behavior you have. Let me check if I have some fat sales, for example. At this moment, they asked me where I can save this file. Here we have, for example, Workspace. In Workspace, I'm going to put in the default. I'm going to call it fact table, and all the columns was identified successfully. And you can add these external files and automatically generate a SQL from, all from, and start analyze this table. Sure, I can select better this information and filter this information, but I can use this information the same way use another data sets we have here. Go to the summary, go to the aggregate a new page here. In the new page, I can add a chart and select it from the right side, the fact sales. At this moment is the first time this workspace received this file. So they don't know nothing about that, but start to understand and what can get from this data. For example, it suggested for me sales by region, sales over time, sales channel distribution, only opening the file. And you can accept the suggestion and look at this. This is the graph they generate for us. I'm gonna change the name, custom. Gonna publish it right now, this information, and enable a Gene create a space for analysis is okay. We'll publish it, and just so you guys understand, you can take advantage from this feature, Gene Assistant, through your data immediately. And ask Gene, what you can show me about this sales fact. You can make open questions. What Genie means, understood, learned from this question. You ask the question and suggest some question. For example, the total sale, sold, how do I sales vary by region? Start, understand the data set and provide some quiz insights about the data. So as you can see here, and if it's good for you, if you work it well, you can show the code, copy the code, close, go to the draft, data in the create from SQL, paste, run. You have to choose here the workspace, the, the place where you and run. And now, if you have permissions to find, let me see where I saved my table. Where I saved my table, guys. Ah, no. Sales fact, workspace, default fact sales. Good. And look at from this table. Can run this query. Now we have a query. And you can ask, look at this is automatically renamed by artificial intelligence. So that's it. What I was talking about is in the lake house, just in moving to the end here, it's right. We have a few time. We already done. I hope you have appreciated the call today, this workshop. I'm gonna finish right now just to know this is the ABI data warehousing and this is Genie. You can use Genie to ask questions about your data. And now you can keep trying and use this information to take advantages in your process. I hope you have enjoyed the session today. Sophia.
Thank you so much. Appreciate it. And thank you to our subject matter experts also for staying on the line and managing all of the questions that came through today. I'm going to keep up the poll for a few more minutes. We'll keep it up through 11:50 Pacific time. And thank you so much. As a friendly reminder, the recording, slides, and everything that you need to know to run the lab on your own time will be provided via email that is typically sent out within 24 hours. So do be on the lookout for that tomorrow. Thanks so much and look forward to seeing you next time.